right, so today we have the founders of Tiger Data, Mike Freedman and Ajay Kulkarni. They're the artists formerly known as Timescale. Uh, Although their logo has remained is almost the same,
Exactly.
the tagline has changed. It's now Postgres for developers, devices, and agents. So welcome to the podcast.
Thank you for having us.
Thanks, Ben.
And today we're going to talk about something you release, which is Postgres for agents. Um, so I guess before we dive in, a couple of disclaimers. One, I'm an advisor to Databricks, which has some activity in this space, but obviously everything I say comes out of my mouth has nothing to do with Databricks. Secondly, what is everything we're going to talk about? What is open source? What's not open source? Is it open source? In terms of what you folks just announced, how much of it is open source?
Some of it's open source. All of it's also available free on our cloud platform.
Okay. Yeah, I just wanted to make sure the listeners know that. So I guess in one line, what problem does this new Postgres for agents solve that plain Postgres with a vector add-on or whatever plugin does not? And by the way, is that the right way to refer to this Postgres for agents, or is there an actual name?
Yeah. So first, I mean, right now we're calling it Agentic Postgres, but Agentic Postgres is Postgres for agents.
Okay.
The way we think about it, it's the first database truly designed for the agent to use for what we call agentic ergonomics. And the whole idea is that agents have become the new developer, right? 80% of Claude code was written by agents, so like Anthropic's only in the future, but we'll be there in 12 months, right? And I think what we realize is that developers and agents are different. And so if agents are going to start writing code, they're going to need the tools need to evolve. And so, being database people, database nerds, we decided to evolve the database.
And so then I guess the word first is a bit of a dubious claim there, if I might say, but whatever. So why I guess continue to build on top of Postgres? I know the answer, but for our listeners, why continue to use Postgres as the kind of foundation?
Yeah, we thought a lot about this actually, and we actually, even though we come from a Postgres background, our first question was, hey, does the database for agents look like something totally new, right? Should it be something totally new? And we went through this kind of thought exercise, really started to explore it. And then we realized that the thing we've learned after being in the database industry for 10 years is that every time there's a new workload, call it time series or vector or whatever, right? JSON, right? People create a new database for it. And all of a sudden you have, okay, relational database with a vector database, with a time series database, analytical database, blah, 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 blah. And now just to build an application, you need 7 databases. And what we realize is that it doesn't have to be that way. Like, why should a developer have to worry about 7 databases and not their application? And what we realized, what we saw with time series and again with analytics and vector is that you see that now with the success of PG Vector is if you can use Postgres, use Postgres because it leads to operational simplicity, which then leads to, I think, better applications, faster development cycles. And by the way, like if you're building on top of a database, you want to know that the database is reliable. And so that's why we picked Postgres.
So I guess what breaks when you point an agent to a traditional Postgres instance, and what had to change?
Let me talk about a couple of things. So I think the first question is how are agents different than humans, right? Some of the ways they're different, maybe they're pretty obvious. Like, instead of clicking UIs, they call APIs like MCP. Okay, cool, whatever it is, MCP. Another way they're different is that, hey, agents don't really remember things like we do, but they can retrieve any context that you give it, right? And so, okay, so search and you can become more of a first-class citizen. Okay, that's interesting. A third thing is that agents you kind of want to give them a safe place to play and potentially mess things up, right? Like, all right, that's right. Another way agents are different is that, hey, they're like very parallelizable. And when one developer could do now with agents, you can have a team of, I don't know, 6, 7, 8, 10, 20 agents essentially working as a multi-threaded team. But now as a result, now can your infrastructure handle that scale? Can your infrastructure can your budget handle that? So all these changes happen. And so what we found is that you kind of have to rethink the database starting from the storage layer. And we talk about some of the changes we made, but like, look, we built what we think is the best MCP server ever built for Postgres, maybe for any database. We can talk about that. We built, even though there's vector search with PG Vector, of course, we improve on it with Vector Scale, which we launched a year ago. But we also launched a full text search, so a BM25, full text search extension. And then we're launching forkable databases, which is essentially fast zero copy forks built on top of a new storage layer. We built a copy and write storage layer called Fluid Storage. We can talk about all these things, but the basic idea is that the way agents work are just different than humans and in so many different ways that you kind of have to rethink the whole experience for them.
So I guess databases, right? So either you're using a database. So in the analytics space, for example, most people just use it, right? So they go to a data warehouse, they run their reports. So you can imagine an agent doing that, and I don't think that requires that much change on the part of the database, right? So then when you talk about
I'm not sure if I agree
transactional,
with you, Ben. I'm not sure if I agree with you.
no, I mean, there's changes, but I mean, you provide them like, I guess what people are calling the semantic layer, and then maybe they can explore and run their reports or whatever, right? So in other words, they can still hit the same warehouse that other people hit
Yeah.
at some level, right? So, but on the transactional side, I guess when you talk about applications that require databases, well, maybe an application that requires a database where the audience is now an agent and not a human is completely different
Yeah, so let me
system, right?
I think at a high level, yes. Let me say about two things. One is we've always focused on what we would call operational databases. So this is one that's powering applications. They're either customer facing, they're kind of serving mission critical use cases. And so maybe it's not like a warehouse or something where all of
Yeah,
your data.
developers might use databases a lot, right?
Yeah, and so if you think about agents, there's actually two different roles that we've often talked about. And we talked in the beginning about vector search. Those were, I think, meant a lot of times for AI applications, applications where you need to retrieve, where you bring these new AI capabilities to the application. I think there's also this large area that is perhaps underappreciated, is that when people are building applications with agents. So think about all the innovations with Claude, with Cursor, with Copilot, with Codex.
Yeah, just
Those,
any kind of software application or
those
system
could
at
be
some point would benefit from a database.
correct. Those could be a traditional application. So you might ask before, why? One answer before is why Postgres? My answer is, well, if now Postgres is the most popular database
For
the question,
humans. For humans.
sure, for humans. So if Postgres is the most popular database for humans, do you think that all of a sudden overnight it gets thrown out and we build something completely new? Or do you think you should look at this and says, well, what are the ways that we should evolve this to serve both? And I actually think that's not, it's certainly serving agents, but it's actually serving both agents and humans. And so the questions about that are, there's the aspect of database as it's serving their customers. There's also the aspect of the database as you're trying to develop new features. And so if you think about what used to be called the developer experience of how do I write new code? How do I modify my database? How do I do that to production to make sure it works? Well, humans used to do that. And a question which a lot of our forkable storage layer is trying to address is, how do we make that work, and how do they make that fit the new kind of agentic ergonomics you want, where agents are trying to write code in parallel? They might be not doing exactly what the human had in their brain. There's this lossy channel between what I speak and what the agent does. How do I get the agent to explore, iterate, roll back when needed? And that's kind of where a lot of our work on fluid storage as this forkable infrastructure came around.
So with agents, right? So one of the things that I think people make a mistake of is they try to anthropomorphize the agent. So in other words, they look at their knowledge team of knowledge workers and say, well, we have all these roles, so surely we need an agent for each role. So then they end up in a complicated multi-agent scenario. So in this context, how do you resist anthropomorphizing agents so you don't end up building a database that has features that agents actually don't need, but you think they do because humans need them, right? So in other words, so the contrast is the vision is, I don't know if you folks followed Agent DB. You know, it's a startup out of Sutter Hill Ventures, right? So their thing is, programs are different now. I mean, basically you have an AI model and a data API endpoint. That's your program, right? So their thing is maybe all we need for an agent is just basically kind of a URL plus model, kind of like SQLite, DuckDB, ephemeral. You store it per task. Versus kind of forking a whole Postgres thing, right? So heavyweight, a whole Postgres system when you don't actually need it, right? So
a couple things. First is, do agents need a new kind of database?
yeah.
I think we would say so. I think AgentDB would say so. Cool, great, right? Second question is, should that new database be built entirely from scratch, or should it evolve?
By the way, I'm a fan of Postgres. I'm just thinking this through with you.
No.
Playing the devil's advocate.
But I think the question is like, should this new database for agents, should it build something entirely from scratch, or should it evolve the thing that already works, Postgres? And if you look empirically through like data, software history, anytime a new system has come up and saying, hey, Postgres is outdated, whether it was in time series, whether it was in, now recently with vector, like anytime it's come up, Postgres is always one. Like there's a reason why PG vector is the most.
These are for humans, though. No.
But my point is that like, whether humans are building a system or agents are building a system with humans, right? The question is it better to evolve the thing that works or build something entirely from scratch? It's always like tempting to throw everything out and rebuild everything from scratch, right? But the relational database model has survived for decades through the personal computer, through the web, through mobile, through IoT, through blockchains, and it's going to survive through agents. And I think, I don't know, it's kind of like saying, hey, we're going to disregard decades of computer science to just because we want to.
So let me ask you this though. Are there applications? So the word database, right? So we think of it as like Postgres, a SQL database of some sort. So, but are there applications where you don't need a full-blown database?
Yes.
In which case, you don't need Postgres.
Those applications exist, but I think that's the edge case. I think it's not the norm.
Huh. Interesting. Because I think there might be applications in the agent world where the agent actually just needs the database for a little while, in which case, ephemeral, in which case maybe they don't need a full-blown.
You could use.
They don't need something full-blown, right?
I think this is a great question. The question with your storage, like with your database, is do we not like it because we think from a feature function it's too powerful? Or are there aspects of it that we think, hey, maybe with agentic exploration there's ephemerality, let's call it. The database is ephemeral, we want to fork, whatever. And our answer is yes, that there are.
You want to bring it up fast and then tear 100%, it down.
100%. So let me talk for a minute what we did. A big part of our agentic Postgres is this new storage layer. And what we said is we actually
And Mike, just to clarify, this storage layer is not open source.
it's currently not open source.
Okay.
No. And partly is because it is an overall infrastructure involving many different layers and so forth. So it doesn't package as well. But like it's powering our free layer, and so anybody who wants to check it out.
So
Nah,
tell us about this storage layer.
Totally. And so effectively, at a high level, you could think about it as we basically provide the abstraction of a block storage layer. So if you're in the cloud, you're running EBS. Most people running in the cloud are running EBS. It's network attached disk. It looks great. A container comes up, it attached to a disk volume, it could use it, and it persists. So if the container goes down, but EBS was kind of built from a previous generation, and so lacked a lot of things. It lacked a lot of elasticity. It scales up slowly, but doesn't scale up rapidly or scale down rapidly. It can't handle ephemerality very well. It charges you per allocation. You allocate 100 gigs, not how much you use, as opposed to build an architecture that you consume only what you use, not how much you allocate. And the biggest thing is it really doesn't support what we'd call fast zero copy forking or snapshots. And what that is at any point in time, you have the ability to snapshot the entire volume almost instantly. Today, it's roughly, and it's yet fully optimized, but roughly 500 milliseconds to snapshot even terabyte scale volumes for us. And at any other time, create a fork of them that is copy on write or zero copy. And so what that means is the additional fork, you have a fully isolated volume, and yet it doesn't use any extra storage. It's still based on the original replicated copy of the storage, except if you do writes, and then the only addition is the difference between what you route and what the original. And so this is not there's been some kind of copy on write file system, but they're usually local, they're not scalable, and generally they're quite slow. The way we ended up, it was 2 years of lots of system engineering. It's fast, it's scalable, and it really allows us forkability. And so when you're an agent, you all of a sudden said, hey, I have the state of my production database that's 100 gigs, and I want to hand this off to an agent or even 2 agents to go. Take a snapshot, give it both forks, and they could both run independent in parallel. I could look at some of the results and take the output of the code and merge that back into my original production volume. So in that sense, it's allowing you to build that workflow that we're used to get, this branching style workflow, but now on top of your database or on top of your data volume in ways that you really couldn't do before.
And how do I talk to the storage layer since it's not open, right? So if these open file formats, I can hit it with all sorts of different tools that.
Sure.
So can I only talk to it using Tiger?
Let's kind of separate for a minute like the open sourceness of a product and actually the network protocol aspect. I think you're referring to let's say Parquet, which is a standard file format. Snowflake or Databricks implementation of Parquet is proprietary, but they're speaking an open standard file format.
Or originally Snowflake was not using Parquet at all, right?
Sure. But what I meant is the aspect of any technology. What we built was, like I said, this is a block storage device. And so every Linux, every FreeBSD in the world speaks block storage. So much like you could basically take any container and attach it to EBS, you could take any container, and we run standard network block device protocols to talk to us. From that perspective, we look just like fluid storage looks just like a block storage device, much like EBS is a block storage device.
So the Postgres for agents, right? So is there a scenario where I'm a developer, I go to your website, I got Postgres and I got Postgres for agents. But I'm a developer, I'm not an agent. Is there a scenario where I choose Postgres for agents?
Yes. So again, a lot of people talk about building databases for AI applications. What we focus on is what we think is the bigger problem, which is building a database for when developers are building with AI. So essentially, every developer today who's using Claude Code or using agents or whatever to build, essentially has become an engineering manager. They've essentially said, okay, now instead of just me, I have a team of people who can work, right? And so at that point, I will still choose Postgres for agents because my team is a group of agents that can use. And by the way, since it's Postgres, I can use it as well. So I think like as more and more code and more developers build with AI, I think you will need a Postgres for agents for development.
Let me give you an example of, if I can, of how development, and this was connected with what was our MCP server, which we could talk about, is interesting, is not just a thin interface to the API, but kind of teaches Claude how to be a better database developer. And so when we, let's say, write an application using Agentic Postgres, you spin up Claude code in the terminal. You basically says, hey, I wanna build an application. One of the recent ones I did is I want to do analysis, let's say, of the blockchain. And so all of a sudden, what Claude Code is, I have my MCP server installed. It figures out a schema. Through the MCP agent, it knows how to do like 5 or 10 different ways to optimize the program to better use the underlying database technology. And then basically it builds a schema, and I will tell Claude, now spin up a fork of your database, install this, test it, whatever, and we'll go ahead and do it. Or if I have a production app, I could be running my production app and I'll tell Claude, hey, this query looks slow. What would you recommend? And Claude would say, well, I analyzed, actually, again, using our MCP server, I analyzed your behavior. I decided that's missing some key indexes. I could do them. And what I'll say to it, great, I'll say, spin up 3 different forks of the database, test the different indexing strategies against a production scale database, a terabyte scale database, and tell me the results. And it can go ahead and do this. And so I view this notion of like building with agents as this like co-design, this cooperation between the human and the agent. And now you have the sandbox or playground where you could actually run this against real scale production data and actually better understand how this would really work, when you need to do it.
So is there the notion of templates in the following sense, right? So let's say I build an agent, but the agent actually doesn't know anything about a certain database or databases. And if you're a human, you look at the schema, you look at certain things before you actually hit the database, right? So what is made available to not the agent that created the database, but the agent that might use a particular Postgres for agents?
Yeah, so we actually called this prompt temp. We called part of the functionality of our MCP server prompt templates, and it's actually also similar to how Claude just launched skills. And so effectively, what it's doing is if I take an existing Postgres database, you basically an interaction of your existing schema and Claude with our MCP tools will basically be saying one tool call is, here's a schema, how do you optimize it? So effectively, you could think about it as we're kind of injecting that knowledge or templates, or injecting that skills where we take our domain specific knowledge about how to build really good Postgres and how to build basically really good data modeling and inject that into Claude. And we basically teach it at runtime or show it enough examples at runtime where it could actually learn how to do this better. And so if you think about the normal cycle of a programmer, you first come up with your code. That's what these MCP tools are good for. And then you could test it. And that's when you could do a fork. And by the way, if again you think about an agent works, you fork the database, you run these things against the fork, you actually get output from the fork, and the return value of your data is going to then inform the agent, did this work well, did it not work well? And that's actually going to go into the cycle by which the agent will get that feedback from actually trying this and figure out if that result is good or if try something new.
So one of the claims here that I'm parsing is that much like the AgentDB approach, which is kind of file-based database, SQLite, DuckDB kind of, whatever you folks have done, it also enables a similar kind of scaling, meaning I can instantly create isolated databases supporting thousands of agent created instances instantaneously, right? So,
Yeah, I don't know what AgentDB does, but what we've done is what Mike
but
talked about.
I can instantly create thousands of these databases
Yes.
in isolation.
So one of our key innovations is fluid storage, which is a new storage layer which enables exactly that. Zero copy forks, copy and write. You only pay for the diffs, and instant forking, which right now is exposed through through Tiger, through the Postgres offering. But we're already working with design partners to actually have that be in other people's products as well, because this idea of like a block store that is essentially agent native is actually quite attractive to a variety of companies.
Interesting. So tell me more about you folks are humble bragging about this MCP server. So MCP servers are a dime a dozen, as you know. Many are
Yes.
unvetted, but you folks are respectable people, so I'm sure
That's
it's
right.
hardened. It's at least hardened somehow, right? So
So
what else? So what else
yeah,
is special about this MCP server?
yeah. So I think what the first iteration of MCP servers was basically as the new API. So, we had REST APIs, we had GraphQL, then we had GraphQL APIs. And the first generation, in fact, probably most MCP servers are basically just a thin layer, a thin shim in front of your API that's meant to give your agent basically access to your API. And by the way, we have that as part of our MCP server. So like again, the agent could call the MCP server, create a database, fork a database, all those things that actually will affect the operations. And yes, we went into a lot of hardening around security as well. But I think the more interesting part is this becomes the channel by which you could teach the model. And in some sense, this is the moment there's a kind of conceptual question about like where models are going. Obviously, there's been a lot of focus on these foundational models, hugely general, but they effectively have to embed the world's information in a couple billion parameters. Then obviously some people are looking at like smaller models that get fine-tuned. And you're trying to say, well, I'm going to not know about the world's information. I'm going to go really deep on this. And that works, but it kind of inhibits the rate of how quickly you change it and how iterate. It's expensive to fine tune. And it also means that whenever you build a new product, you have to have a new model. So like, does that mean when I'm in a terminal, I'm going to use like the Postgres model for something and the Kafka model for something else and the Kubernetes model? I think we're still going to have a coding model. And so then the question is like, how do you teach this coding model special stuff? And that's where, I don't know where, I'm sure we're not the first to do this, but frankly, we hadn't seen people do it, where you're basically, taking the decades of knowledge that we've accumulated here at timescale at like building and running Postgres at scale, and using this to generate a lot of both prompts where we could include under different scenarios. Basically, Claude asks a question, we take, it gives us a schema, we analyze it, and we return it a bunch of information that it could use to figure out how it should better handle this data. As well as through our things, we gave access to a lot of retrieve around Postgres docs and Tiger docs and everything. And so again, it could make better decisions about its use case. And so I could see a future where, you start having this type of MCP server for Kubernetes or have this type of MCP server for streaming applications. And kind of we're making that, we're building what we think is the best Postgres MCP server, not just to call a cloud, but really to teach Claude how to do Postgres better.
Well, by the way, when you folks built this, right? So obviously Postgres associated with structured data, but the people who have some familiarity with Postgres knows that there's all these extensions and plugins like PG Vector, PG AI, right? So that allows you to do more than just structured data. But are people really using Postgres for unstructured data?
I mean, JSON is probably one of the large use cases in Postgres. So certainly it has its point. I think Postgres is primarily used as an operational database. I view the world as there's the pillar of operational databases, which I think as Postgres is the leading one, and kind of like the non-operational, the lakehouse of the world, where you're just going to dump a lot of your completely, I don't know if I want to call unstructured, but even uncleaned up data. I think Postgres often has, very commonly people store JSON in Postgres today, but it is generally cleaned and ready for usage as opposed to just like a bunch of whatever comes across your desk.
Of course, Matei, Ali, Reynold, and Patrick will say, well, HTAP is coming around, we don't know when, but we're working on H.
I think Databricks just made a big bet in Postgres. So I think if anything, Databricks' support is talking about how Postgres is the future.
Yeah,
right.
but that notion of HTAP is kind of making a comeback, but I'll believe it when it happens.
Yeah, I mean, I feel like HTAP has been making a comeback for 15 years. I think that's it.
Now maybe we're closer. All right, so one of the things that the people in the agent space lament a lot is state and memory, right? So managing state, managing memory. So obviously databases are probably a good ideal solution to this. But it seems like this is still an area where people haven't arrived at a consensus for what to do, right?
Yeah.
So some people are using databases, some people have their own thing, but my prediction is that databases will win out.
Yeah, I mean, I think
we agree.
We agree. I think that very much follows our view of what agentic architectures look like. And I think they really have three main pillars. It is the agent code, which is kind of the control plane. It is the model that they call into, and it is the database. And our view of the world is all of your state, all of your memory basically sits in the database. And so if you have the right database, it can keep your application state. It could be the database that backs even your durable execution of your models. It is your analytical, it could be your operational analytical data, your history. It could be your memory. It could be search. And particularly, I think we're going to see this rise of more people building internal apps again, where you don't want this sprawl of, a dozen different ways to store state to power this one app. Keep it simple, keep it elegant, and move all of your state to the database. So we very much believe, and we believe obviously, what we're building with Agentic Postgres is ideally suited for these type of applications.
Yeah, my observation is that the state and memory layer is something that kind of like undergoing what happened in time series databases in some ways, right? So someone can build it in a weekend and they think, oh yeah, this is it. This is the answer. But then someone else will come to the same conclusion. So then now you got 100 of these. But then at the end of the day, you already have systems that are somewhat kind of well suited for this layer, right?
Let me talk about something that we built internally that we're open sourcing, that we've open sourced and released, which is the name is called Eon, which we're called Tiger Agents for Work. And this is an example of the type of architecture. So
Eon, not neon.
Eon,
Yeah,
E-O-N.
Yes, Eon.
E-O-N. Yes. Eon was always an internal mascot we had with the tiger, a time tiger anyway. And so basically it was, we built it internally. It is effectively an agent that sits in Slack. And it basically incorporates into, again, a database, incorporates information across your organization. So it pulls in the full feed of all Slack history. It pulls in all of your GitHub data, or it could query GitHub, could access like linear, pulls in your docs, and effectively this becomes anybody in your company, anybody at Tiger right now, talks to Eon all day, asks it questions, and Eon as an agent is smart enough to know, do I get this from Slack history? Do I get this from my docs? Do I get this from my Salesforce support cases? And it becomes this kind of unification of companies' knowledge base. Now, there are many companies that are building these commercially as like AI-based SaaS apps. But this is the view of we think that this is like the type of internal apps more and more companies are going to want to build themselves, because out of the box, and agents could do a lot of things really simply. And then with some tweaking, or maybe with some additional prompts they could really customize it for their unique settings, or slap in a new MCP server and be able to talk to a unique data source that they might have. And so to your questions, one, we didn't just build this, but we're using this ourselves. And so right now we're experiencing how you build memory on top of this. And I think what we found, like you said, is it's like people got way too theoretical and academic about how to represent memory for agents. But a lot of times it's fundamentally just state. And you need to manage state in different ways. Sometimes you always inject it back into prompts. Sometimes you look it up. Sometimes memory is unique to an individual because it's like scoped, from a security perspective or privacy. Sometimes you want groups to share it. But ultimately, memory translates to state and different ways to query it. And databases are just really good at that. And we found it a powerful framework to build these type of things.
So if agents can provision, fork databases on demand, are there any specific guardrails that need to be put in place? I mean,
I think there's a couple things. One is obviously, like many other things, rate limiting. We have obviously security around. You need proper tokens if you could do that. I think things that we are also probably will be kind of on roadmap is ways that we could do partial masking of data. So if you want to give access to the agents for some of the data, not all the ones, as part of our MCP server, you can give access to an agent to have read-write access to the database, particularly in a fork. And we've also built a bunch of hardened read-only access where it's very hard for the agent also to break out of that if you want to either do a query against production or even in a fork don't want to give it read-write access. I think this is an area of also constant.
I think you see this discussion a lot in different people using agents for software development, where there's the metaphor of a long leash versus a short leash. And I think that the general best practice has been, don't give your agent a super long leash, give it a short leash and make it check in so that you make sure it stays on the right track. I think there's something similar here, but I think this is an area that as an industry, I think we're kind of developing together.
I'll also say one other thing. I mean, one view of that is, okay, the agent has access to prod, and we're going to try to put guardrails around that. We probably don't think that's the great thing to start with. And so the whole idea of forkability is you don't give your agent a lot of access to prod, where if it wants to delete your database and so the notion of forking and that is trying to allow, kind of jokingly call it, let your agents cook, but do so in a safe way.
now, like I said, in the analytics space, people have kind of are all building some notion of semantic layer, a term that I actually don't like. But basically, it's is knowing enough about the lakehouse or warehouse so that if you're going to do some sort of text to SQL, it has better context, right? So in your case, you're now talking about operational databases, of which there are going to be a lot more of them, right? So what is the equivalent of a semantic layer, or do you have one in this context?
I think you do have one, and we.
Or are you actively building?
Yeah, I mean, I think you do have one, and in fact, many of the things like we talked about the MCP server, that's kind of injecting back the semantic layer to the agent. I think the problem then the enterprise data warehouse looks a little different. I would say there's a lot more of these operational databases.
Yeah.
But it's not typically that we're trying to do let's say a text to SQL query across 1,000 at a time. You're generally exploring smaller subsets of them. So generally the text to SQL one is an easier problem in this context than if you say, hey, I have access to every lakehouse file that I have across my whole organization. How do I make sense of that? That's the problem.
Yeah, I think a semantic layer is just another way of saying more context for the agent.
Exactly. Yeah.
I think that context could be provided through like a layer. It could be provided through kind of prompt injection or just prompt templating through MCP. I think there are a few ways to do it. The database can expose it directly. So I think in general, yes, the more relevant context you can provide an agent without flooding it with information, the better. But I think there'll be different ways to do it. And I think to Mike's point, the operational database problem is a little different than the enterprise data warehouse problem.
One thing I'll just add to this too is I think Postgres is the warehouse for most startups in the early phase. And so what typically happens, they start having their production database, they want to ask questions. Today, they're like, well, do I migrate to the database? I want to ask questions to my agents. Claude itself is pretty good at doing text to SQL, particularly if you give it access to the schema. But you don't want to do it against in prod. Well, if you have Agentic Postgres and forkability, you fork prod any time your BI team, product team could start having their agents ask questions about immediately. And that avoids the safety guardrails problems that you've typically had with agents in the past.
This is actually the point that I was pushing back on you earlier, Ben, when you were like, you're not sure if you need a new kind of database for analytics, because what we found, we've heard this from a lot of companies, is that like everyone's first data warehouse is a replica of their database, right? And every startup I worked at has had an analytics replica or a read replica for analytics that the data ops people, the rev ops people use, right? And then it's like, okay, cool. Okay, how far behind is that? Okay, oh wait, you're hitting that. So now I need my own. And now you have three of these things. So I actually think for analytics, having fast zero copy forks just for anyone to do their analysis without worrying about, you can do schema changes, do all kinds of things without messing up anyone else. And then you can delete it right afterwards and have the agent do it. I actually think that's a really compelling analytics use case that maybe you'd see less of in the enterprise. But I think for the majority of companies for whom their database, their data warehouse is just a replica of prod, I think it's actually quite compelling.
So there's one dimension, Mike, where the operational database is more complicated, right? So in the case of the warehouse or lakehouse, there's only a few of them. So you go, I need marketing. I go to the marketing lakehouse. In the operational sense, I'm an agent, agent is just really, honestly, you talk to these startups, an agent is basically a prompt. So I have a prompt, and then somehow this prompt needs to know what slice of the operational database or which one, where. So how does that work?
I mean, today I think we haven't
It has
yet.
it has to have some knowledge, some context, right?
I mean, I think there's a bunch
Like
of
a transactional system could have 10,000 tables. I don't know. I mean, the ERP systems are incredibly complex, right? So
Sure. I mean, usually not that. They're usually built a little bit differently, but I mean, if you're asking, there's probably a layer where you could discover of your 10 operational databases which one there is. I mean, today we're mostly handing the agent the database to look into and its query. I think I would
right
maybe
now that's the scenario.
Yeah, you basically point the agent
Look here, right?
Yeah, but I mean, again, that's something relatively simple. I mean, you could put in your Claude MD rules or something else, like here's my 10 databases for this. I mean, those are.
But you can imagine going in and go, I have a Jira ticket I have to resolve, which involves some database, and then this Claude code will burn through and kind of brute force look at every database until it's solved.
I'll say two things. One is, I think your characterization of the lakehouse being simple compared to the database is really the opposite typically. What's interesting I found actually, and lately,
I mean, they have both challenges. Let's put it that way. Right?
I would say something, I would actually say something of also interesting is that we've recently found that there's a lot of companies building AI sandboxes today. And you think that a big use case for the AI sandboxing would be coding. But it turned out that a big use of AI sandboxing has also been in analytics, that people basically want to write little description and then run that analytics in a sandbox. And given the lakehouse, given it's disaggregated, given anybody query the lakehouse, it seems like an interesting question about why don't these queries happen directly against the lakehouse? And I think what's going on is that people are so worried about basically kind of dirtying the pristine copy of their enterprise data that they're trying to pull their data into these little forks that are ephemeral and are thrown out afterwards. And so I think that just the same way that people are finding the value of this like ephemeral forkability for the lakehouse, I think we're seeing all those same use cases in the database. And to Jay's point, I think for a lot of companies out there, specifically those early stage startups, their first warehouse is just their Postgres. And so this allows that type of data exploration, not just coding exploration, for a lot of companies as well.
By the way, so is there a flywheel effect here in the sense that, I have all these agents standing up these databases and working in isolation? They must be learning something about these databases. Does that get captured somehow? Like agent one tried something, it worked. So therefore, when agent two comes back later, or agent two uh, might benefit from that learning, right? So do you folks
I'll,
kind of,
I'll,
I
I'll
guess
share
this goes to like a combination of what's new with logging and observability in this context.
well, let me share just my experience using these agents. I mean, coding with Claude Code and
You
these agents.
code, man?
I do now, man, dude. I thanks to
You
Claude Code,
vibe code, huh?
I'm
You
back
vibe
in it.
code. Huh?
I'm back in it. I mean, I don't know, man. It's I'm actually in the code, right?
Yeah,
Using Git,
yeah,
He
whatever.
started as a
I,
software engineer, but left for a while.
yeah,
yeah, yeah, yeah.
yeah. You know, I like to say I'm great at hacking on projects, but I would never hire myself as a developer. That's what I say.
Yeah,
No, but it's been a lot of fun. It's been a lot of fun.
yeah.
Actually, I know a lot of people like me who are former developers who went into like product management, entrepreneurship, whatever, and are like, "Oh my God, I'm building again. It's so much fun." Anyway, my experience has been number one is, use the same, Claude, whatever API, for all your agents. There's something funny that the LLM does. Or the LLM actually kind of remembers things, or maybe Anthropic is doing something on their side. So there's a little bit of that happening over there where I'll be like, hey, I didn't tell you this in this session, but
I,
somehow you knew.
I don't want it to remember anything because that's IP for me, right? So
Yeah, there we go. Well, then the second thing is there's definitely a world in which, and I think, we just launched today, so, we're not quite there yet, but we're exploring it. Definitely a world in which we can allow you to explicitly create kind of memory for your agents, again, stored in the same, database. Um, so to enable this type of knowledge sharing, information sharing. But honestly, I think most people today are just at step one at like building with agents. That's not where the market is, but I think there is something interesting there.
by the way, so this goes back to that notion of the semantic layer, right? So in the warehouse lakehouse space, they look at logs, they look at organizational structure, right? So Ben is the main analyst for marketing, Ajay is the main analyst for sales. So therefore, when I have a marketing question, I look at Ben's SQL logs and reports and so on and so forth. So I'm assuming there should be some notion of logging and observability specifically for this notion of Postgres for agents. Am I wrong?
Yeah, so let me talk a little bit about how we're thinking about memory, and maybe that would help. One is, what is memory in general? Is memory is some form of structured retrieval problem. The first version of memory, what most people do is just store a bunch of state, a key value store, then dump all the state out of it. That works up to a scale, and then you blow out your context to one of your models, and you have to be more selective. So ultimately, kind of memory is really a type of prioritized search problem of what are the things that I should do that I want to retrieve back. As part of Agentic Postgres, what we launched is we launched what is kind of the two pillars of AI search. One is kind of the most advanced vector search, which we launched through Vector Scale last year. And today we embedded what is the kind of the best keyword search algorithm, BM25, now in Postgres. And so together you could do hybrid search. And in fact, in Postgres, you could do hybrid re-ranking. So you basically take these two types of search, you get back, and then you can compare the results. So one is
without licensing a vector database.
correct, and it all runs in
Yeah.
Postgres. And
Okay.
so one, I should say that's kind of like the search building blocks that enables memory. So I think of often memory and search together. I think beyond that, there's a couple pillars that we've really liked as.
But those are in the database. I'm talking about logging. Yeah, yeah.
Yeah. And so then there's a couple other things. One, which is kind of view memory, and I'll come back to logging in a minute, but view memory as being transparent. I think Mistral wrote well about this, that kind of some pillars of memory. It should be enumerable. It should be transparent. You should be able to upgrade or delete it. And again, if you recognize that ultimately your memories are stored in a database, it becomes pretty easy to imagine how you could have CRUD-like access to memory. The second is scope. One is like, and you can think about the wrapped around security. Is this memory unique to an individual? Is it unique to a group? And again, if you think about this as being state in a database, much like we've always known how to handle proper access to different state in applications, it kind of translates naturally to this. I think the third thing is kind of what is a loop has to do with learning and summarization, which is kind of one of the new parts about dealing with this AI type of applications. Is you might actually store raw memories in your database, but there's also this synthesis step where you keep traces a lot of things, you synthesize those down, and then you store the synthesis of those in your database, and those become your memories. There's a couple different ways you can handle this. One is you just use the LLM itself to summarize. So you're part of this loop, you collect a long communication, you use an LLM to summary, and then you store the key points of the summary in the database. I think another part which you're getting into, which some memory layers explored, is where they have a form of graphical representation ontology of these are the different people in the organization. This is like these graph knowledge representations.
But you
Again,
can store those in a table too.
of course, you could sort. So what I'm saying is you don't need special graph memory to do this. These ultimately just became relations in a table. And so I think that we're approaching memory very kind of bottoms up, building what we found to be useful. But ultimately, a lot of these things are very easily represented in your database. You asked about logs. I think tracing a log is just similar to learning. There's different ways you could like collect outcome. If you think about this as like a form of reinforcement learning, you collect outcomes in one way.
I guess, Mike, do you envision a scenario where you actually even store the reasoning steps in Postgres, so that if something goes wrong with the agent, for diagnosis, it's already in the database?
It's an interesting idea. I mean, I think no, we'll think about it. Yeah.
I think the one in that is an area that has gotten really popular in for powering agents execution, especially chain of thought, is durable execution. And there's a bunch of companies that actually build these layers of durable execution. If you look at them, the thing that's underneath their durable execution layer is typically a database. And for most of them, it's Postgres. And so if you actually think about that, the agents are doing this control plane of steps from A to B to C, and the look at where they are is if they failure to bring it back, typically that state about where they are actually being stored in Postgres. So it's an area that kind of in some sense, Postgres is
because if I'm using a reasoning model and it's emitting steps, you might as well capture and put that in Postgres, for just in case I need to figure out what happened, right?
That's actually how we built Eon. We used Postgres as for our own agent as a lightweight queuing system.
By the way, as Mike was talking, it dawned on me that actually this is great, because basically in the agent space, there's two things, right? So can I use this data, which Postgres will take care of, because Postgres has all the access control, right? So, and then the other question, which is trickier, is should I use this data? But maybe that's where the relevance vector search, hybrid search helps, right? Is this the data I should be using, right? Winding down here, right? So you folks have already kind of made the argument, I don't need a vector database, right? So
No, we didn't make the argument. The market did.
the market did. Yeah.
Market did.
So beyond what we've talked about, right? So what other layers of the stack you think are still mismatched if the user is a machine, right? So now we talked about databases, right? So what other areas of the, I don't know, software stack needs to be reinvented for agents and machines?
It's a good question. Um, I mean, my gut says probably everything, you know? Now, in some places, the changes might be smaller than others. I mean, there's some companies out there that are, inventing headless browsers for agents, to use, right? That's interesting, right? Uh, I think IDEs are already becoming agent native. That's interesting. Um, I think documentation, actually, I think it probably has a lot of room to go because right now it's just like, I don't know, you can just search it, but I think it's, what we do with the Postgres docs, which is semantic search and full text search and prompt templates. Like I think there's something interesting there. Um,
What about caching? I guess the database takes care of caching. And if the
I
database
think
is
caching,
designed
I
for
think
machines, right? So,
I think caching is an interesting area that needs still a lot of technical work. For 50 years, caching was exact match. I think in this agentic world, it's like close enough match, semantic match, and it's kind of ill-defined. And so I know people are throwing problems behind it, but I think there's interesting work to be done in caching, actually.
so by the way, even just looking at databases, a lot of database specific tools were made for humans. So are there database tools that need to be reinvented for agents?
I think it was, one thing that we found uh, really powerful. So one thing because we run a large fleet, I'd say at Tiger, outside the hyperscalers, we probably run one of the largest fleets of Postgres databases in the world now. And we from early on,
Outside of Databricks, right?
uh, uh,
No comment, no comment.
um,
I mean, it depends. How many databases does Databricks run? Give that number because then we can
Oh,
compare.
I can't, yeah.
um, uh, one thing that we did from it is we built low-level instrumentation onto our fleet. And so this was to build a product for our users so that we could basically give them per query information. So we are collecting kind of at the kernel level statistics about almost every query they have in our system, serve it out of Tiger, out of Timescale DB because we built an analytics database. And the interesting thing is that collects data about individual query execution, memory, buffer usage, explains. I think humans are not great at using it yet. And because what we find is that the better thing with managed databases is that it lowers the bar to entry, so you don't need to be a database expert to use them. Of course, I can give you all this fine-grained database, all this fine-grained data, but you often have to have a deep mental model of how this translates to behavior and how that query behavior to do it. And that's a really interesting way of, again, extending and making the agent an expert. So initially, our MCP server going back was making you an expert for writing, for building an application. And I think one area of focus, once we're powering and once we have all this data, which kind of we could only do because we've instrumented at such low level, we can now make the agent also an expert at running databases. And so I think we're going to see across the field, agents get much more into the SRE game. Probably for a long time, still have human in the loop, but it's going to replace run books. I mean, run books will radically change, operations will radically change, and so I think this is actually a really exciting time.
So in closing, so it sounds like your focus on enterprise settings scenarios. So in the cloud, so you don't care at all about really lightweight scenarios like edge or anything like that, right?
Well, a couple of things. I mean, I think the opposite of enterprise is not edge in my mind. Like I think I think most of this work today, most of the applications being built by agents are actually new, right? Like, of course, there's some work with existing code bases, but most of it's new because like you're playing with it. So I actually think we're seeing already like the most interesting stuff is in brand new workloads, typically by people in startups or in hobby projects. Um, I think some of that is in the enterprise too. There are people in enterprises who are kind of building new things as well. But I wouldn't say enterprise versus non-enterprise. I would just say mainly new workloads versus existing workloads. Um, yeah, I think Edge is interesting. We see a lot of Edge, obviously, in
But
the
that might be
traditional.
more, Ajay, that may be more the province of SQLite or
Yeah,
DuckDB or.
yeah. I mean, I think it depends what you mean by it. I mean, look, I mean, for the time series, the time scale side where we started, we see a lot of Edge deployments of Postgres. But yeah, I think that's different. I think this world is really early, and what we mainly see are people building kind of new applications with agents.
And so then the plan for open source, is there
Um,
going to be more open source?
uh, Two things. One is, from the beginning, we are an open source company. So TimescaleDB, a lot of our vector scale, all open source, and so we really embrace that as part of our community. Um, One thing I also wanted to add is that with this part of this announcement for Agentic Postgres, we also launched our free tier. And so when you're talking about who you're serving, one of the reasons we could serve a free tier is because of these new technological architectures we built about very ephemeral and efficient, allowed us to now build a cost-effective free tier. But we think that is open for experimentation. So those builders could be from a large company, but it's also a lot of the hobbyists, or it's the platforms who are building the coding agents themselves, who themselves want to have underneath them
Yeah.
a platform that supports this type of ephemerality.
And
So
what's the limitations of the free tier?
free tier right now is that service people signing up get two services, 750 megabytes of data, forking, et cetera, and a lot of the insights and metrics and 24 hours point in time recovery, the maturity of the cloud platform that we've already built.
Oh, so you're basically like one of the cloud customers, except there's some sizing limitations, sounds like.
Correct. So they're running on our cloud, have many of the features of our kind of paid customers, but it's limited by the number of databases you could run and size, because those ultimately translate to resources for us. But the easiest way people get started, obviously, they could sign up, or we have a CLI. It's one line, and they type Tiger service create, and they have a database up and running.
So besides PG Vector and PG AI, are there any other plugins in Postgres that you think people need to know more about?
Timescale DB, that's another one.
So are there plugins specifically for multimodal data in Postgres? No. I guess that's the model takes care of
Yeah,
all
I,
of
I
it.
I think extensions are what enable multimodal data in Postgres. So
Okay.
timescale DB, time series, PG vector scale, vector, JSON Bs, I think is native,
What
PostJ.
is there a reason why you just don't default to PG vector scale? Why even bother using PG vector?
Um, there's no reason not to use it, but effectively, it's at this point better well known, and the advantages of PG vector scale don't appear until larger, kind of 50 million, tens of millions of vector embeddings.
Vector scale, it also builds on PG vector. Like it's not one or the other, they're complementary.
And then the thing that Mike described earlier, the BM25 and hybrid search, are those are
Yeah,
not Postgres.
BM25,
Those are yours.
BM25, we implemented this in a new Postgres extension, PG text search, and that's something that we built in house. Yeah.
And then, but anyone using Postgres can use it.
It's available today on our cloud.
Okay, so it's not an actual plugin available to everyone using Postgres.
It is implemented as a Postgres plugin. We haven't decided yet exactly if we want to make it mostly available on our cloud or open source it.
And let me make this decision for you. We will make it available to everyone. And with that, thank you, Mike
With
and Ajay.
that, thank you, Ben.
Thank you, Ben.
Thank you, Ben, for having us.